Hi, Seth here. Welcome to the channel. Let's see what we have here. Cute little monsters for Christmas. That took around 1 minute and 9 seconds. Let's see if I can generate it faster. "55 seconds. This is SDXL, by the way. On an nVidia RTX GPU, you can improve the performance of 1111 by generating custom TensorRT engines. It has its limitations, but you can give it a try. Let me show you the correct way to do it, without any errors. Before I start, I want to thank all the members who joined the channel in the last 2 weeks. The support is very much appreciated. This tutorial is not recommended if you are starting with Stable Diffusion, as most of the stuff I am showing is still in the early stages. Many issues must be ironed out before this method can be easily adopted. Please follow through with the tutorial only if you already use 1111 and are willing to have a separate manual install. Many extensions are not supported. ControlNet is not compatible. So, there are no IP or text-to-image adapters in the workflow when enabling this extension. Other non-ControlNet extensions may be supported. I have tested ADetailer, and it works. Regional Prompter and similar extensions may also work, but I have not tested them. You can bake in non-SDXL LoRa's with a predefined checkpoint and train the engine. However, you cannot train LoRa's for SDXL. I will explain other limitations as we progress in the tutorial. We would be having 2 versions of automatic 1111. One, which would be your existing install. We will not touch that. The other would be the developer branch, which would go in a separate folder. At no point would we mix your existing workflow with the TensorRT extension. You can bring in compatible extensions, models, etc. from your other workflow to the dev branch. TensorRT extension for SDXL is only supported via the dev branch. This is an official extension by nVidia to bring support for the WebUI interface, enabling it to use the Tensor Cores in your RTX GPU. Tensor Cores are specially designed NVIDIA GPU cores, which enables mixed precision computing. In other words, they accelerate deep learning and AI applications as well. If you are on a desktop grade 4X or 3X series GPU, these cores are probably used for ray tracing in games. Let's take this white line as a measure of time taken for the image generation. The extension allows you to train a predefined checkpoint with a predefined set of resolutions and a predefined number of batch processes to create a profile engine. This then gets loaded in the GPU's VRAM. Once this is loaded, the GPU then reduces the overheads during the process of image generation. Xformers and PyTorch are heavily optimized already. However, some overheads are still reduced by the Tensor Cores. For example, if you have trained correctly, then a batch of 1 with 8 images gives these results, while a batch of 8 with 1 gives similar results. I did not test at higher batches. All testing was done with SDXL base checkpoint, 1024 resolution on a 4090. You should already have Python and Git installed. For the tutorial, I am using version 3.10.11. If you are on an older version, I suggest you upgrade. Download the 64-bit version and make sure you tick Add to Path when installing. Download the latest version of Git as well. I will leave all the links in the description below. Next, go to the WebUI GitHub page and scroll down. Download this zip file. After extracting, run the activate.bat file and let it finish. Now, go inside the folder and run the WebUI.bat file. This will download requirements and create the virtual environment folder. After the UI opens in the browser, close it along with the command prompt. We need to switch to the dev branch of Automatic A1111. To do that, go back to the main folder. Right-click and open a terminal. Type this command, which will list all the branches available for switching. The current branch will be at the top in green with an asterisk next to it. To make the switch, type git checkout, followed by the branch name, in this case, dev. Now, verify if you are on the dev branch. OK, close this window and run WebUI user.bat. Go to the Extensions tab and paste in the URL for the TensorRT extension. This takes some time. After it finishes, it will give you a message. If you look at the command prompt, you can see a bunch of errors. You might get different errors. If you don't get errors, all well and good. In any case, go back to the browser and click on Apply and Restart. If on relaunch, you get this entry point not found pop-up, it means there is something wrong. This keeps popping up every time on launch. If you go back to the browser, you can see the extension, but I suggest we first fix that, and then try out the extension. Close everything and return to the main folder. Delete the venv folder. We need to rebuild it. Go to Extensions and delete the TensorRT folder. Now, click on the WebUI.bat file again and let it run. This will regenerate the virtual environments folder. After it finishes, the UI will open in the browser. Just close it and the command prompt both. For this to work, we need to use the command prompt, not Windows PowerShell. The commands in PowerShell don't work for me. So, close this, and from the Windows Start menu, search and open the command prompt. You need to paste the folder location path in the command prompt. I have it installed on a different drive. I will first change the drive letter, then copy the path from Explorer and paste it here. If installed in the same drive, type cd space and paste the path. Now, type the following command to activate the environment in this folder. This will ensure we don't mess up anything for your main 1111 UI. Double-check if you can see venv before the path. Make sure that TensorRT is uninstalled. We deleted the folder from extensions earlier, but still. This command will clear the cache for a fresh download and install. Install TensorRT with the following command and link. I will post all these commands in the description for easy copy and paste. The orange text is not an error but a warning. You can ignore that. The next command is one of the main reasons why the extension does not automatically work. This will uninstall cudnn from the virtual environment as we don't need it. Next, we will install the other requirements, starting with onnxruntime. This pip upgrade message keeps popping up. Let me upgrade it before proceeding. Now installing on Next. This is the protocol buffer version compatibility error. Don't worry about it. While installing the extension, it downgrades to the correct version. Installing the last requirement for the extension. Let's test and open WebUI.bat. Deactivate the virtual environment and type the following command. Ignore the Xformers for now. I will install it after installing the extension. Reinstall the extension as shown earlier. If you see this, it means it should be working fine now. Also, it downgraded the protocol buffer to the correct version. Apply and restart UI from installed. Perfect, no errors. I am checking it one more time. Closing and relaunching. Okay, let's fix the Xformers and set up the correct launch command arguments. Activate venv. Then type in the following commands. There is a new version of Xformers, which is compatible with CUDA 12.1 and PyTorch 2.1.1. Right-click the WebUI user file and edit it in Notepad. Don't put anything else in the command line arguments. You can ignore half VAE and just keep Xformers. Any other commands besides these two might cause errors during image generation. The extension is now successfully installed without errors. Before we proceed, there is one last thing you need to do. Go to the nVidia control panel. You can access it by right-clicking on the desktop, show more options. Go to Program Settings and click on Add. Here, browse to the location where Python is installed and select the python.exe file. Scroll down, look for a setting called System Memory Fallback Policy, and ensure it is selected on Prefer Fallback. This allows the GPU to use the RAM available in the system when running the Python application. Training RT engines for SDXL is VRAM intensive. For the resolution range I trained on, 24 GB of VRAM was insufficient. 1 out of 3 runs had a crash. By doing this, it started using my system's RAM and gave a single warning, but it worked without any crashes or memory errors. Note down the checkpoints I would be using for the tutorial. You can copy and paste models from your main Stable Diffusion folder. I will put the links of all these checkpoints in the description, along with the required VAE setting. These 2 extra tabs have to be manually enabled from Settings. It would be best if you did that, as the engines are trained on the selected checkpoints and VAE. Go to the user interface in Settings. You can add them here by searching. There are 2 tabs here. I will first focus on the RT exporter. It has some default presets, but I will show you a custom preset that should work for landscapes, portraits, and square formats with upscaling. Static is one fixed resolution with one fixed setting. It's faster but limiting. I would not recommend it. Dynamic trains on a given range of settings. I use the 768 to 1024 dynamic option. Let me explain static first. After you select it, expand Advanced Settings. Static does not give you any minimum or maximum options. It only gives you the optimal option. If you want a fixed resolution, say 1024, and the prompt token size does not exceed 75 tokens, only and only then, go for static. However, you cannot upscale here. You see, if you want to upscale, you will need to train 2 profile engines. Say one is for 1024 and the other is for the upscale resolution, say 2x, 2048. The problem here is that for the very first time, the generation is slow as it loads the engine into the VRAM. So, the first generation will always be slower. When you do a high-resolution fix with any upscale resolution, it will switch the model for that specific upscale resolution. At this time, it unloads the current and reloads the next profile engine. This process consumes so much time that the benefit of faster generation is completely gone. nVidia knows about this and has to come up with a way to fix this switching and somehow load both engine profiles at once. If that is currently even possible with consumer-grade VRAM of 24 GB. In my testing, some generations were faster without using Tensor Cores because of this switching. I generated a profile engine using this preset and tested it with some prompts. I was getting too many errors. I ultimately figured out that the errors were because the prompt token count exceeded 75. And this 75 includes both positive and negative prompts combined. Let's understand the dynamic option. Here, anything beyond the range minimum or maximum will give you an error in generation. Let's take the minimum batch size. Say you put it at a value of 4 and max at 8. In this profile, you can only generate between values of 4 and 8. Anything less or more will give you a profile not found error. And then you have an optimal value. In this example, you can keep it anywhere between 4 and 8. Say you keep it at 6. It means that the generations will be fastest at 6, costing a slight performance loss at a lower or higher value besides 6. I want to have the option to generate a batch of 1, but would mostly be doing batches of 4. I will therefore put the optimal and maximum batch size at 4. This same principle applies to the height, width, and token count. Here are some things to take note of. The minimum height and minimum width should be the same. The same goes for the maximum height and width. For SDXL, the optimal height and width can only be 768 or 1024. Any other value will either crash on profile generation, not generate any images, or will have zero performance gain on generating the images. For non-SDXL, optimal height and width choose either 512 or 768 only. Same issues. These are the recommended SDXL resolutions. I prefer to take something like the 896 as the minimum value, and say 1536 as the maximum value. This would allow me to generate a square, portrait, or landscape and little room to upscale depending on the resolution. I would increase the max token count to 750. Another thing you should consider is the greater the distance between minimum and maximum values for batches and resolutions, the heavier the profile engine. It means that when the profile gets loaded, it will take more VRAM. The last step would be to select the checkpoint and matching VAE. Make sure that SDUNet is set to none. For each checkpoint, you have to train it again. The first thing to note in the command prompt after hitting export is this part here. If this does not show, the export to onNext files is unsuccessful and would give some error. After some time, depending on the GPU, you will get a message saying exported to onNext. At this point, it will start converting the onNext file to the TensorRT Engine Profile. The generation of onNext is only once per checkpoint. Based on that onNext file, you can create multiple different profiles. Because of the wide range I selected, I do get this warning, but there are no errors. I did get errors and a crash when trying to expand the resolution to 2048. Another thing to note is that when you open the WebUI, do not do any generation if you want to export. It will cause memory errors. Directly go to TensorRT and export. It took my system about 7 minutes to generate this profile. After it finishes generating, you will see a UNet onNext and a TRT folder with files in them. I will upload all these files for the channel members via the community post. However, I am unsure if it will work on 3X series GPUs. I am sure it will work in 4X series GPUs, but I am not sure about the minimum VRAM required to run this. So, let me know in the comments if you download and try them out. LoRa can be baked into the profile engine, provided it's a non-SDXL checkpoint. Just select the checkpoint, VAE, and the LoRa model, and it will generate another RT file with the LoRa included. Let's do a quick test. I am using the Juggernaut XL checkpoint. I would also use ADetailer and enhance the face and eyes. I trained this profile to do up to 1728 resolution. I get a 1.5x upscale on a portrait. When upscaling, ensure that the base and upscale values are divisible by 64. If not, the generation will give an error. When using ADetailer, make sure that you do not use a separate checkpoint or VAE. If using a separate height and width to enhance the face and eyes, ensure that the resolution is defined within the profile engine. Without using TensorRT, it took about 59.4 seconds. Let's check out how fast it is with the RT Profile engine. That's about 43.2 seconds. The error fixes shown in the tutorial may be fixed at a later date by a newer release. However, the core understanding of TensorRT and profile generation settings would remain the same. I hope the tutorial was helpful. Until next time.